Hello! Alright, welcome to Physics Lesson 10.2, Simple Harmonic Motion. I bet you think that I'm going to thinking about saying something silly, and that's just not going to happen. So, tough luck, because it's not going to happen. I'm just going to do this lesson, and you're going to listen, because that's what you want to do when you watch one of my videos. Okay, so lesson 10.2, simple harmonic motion. Before we get into simple harmonic motion, I want to talk about speed and waves. So a wave speed is a rate at which energy is being transferred, and this rate is only affected by the material or medium in which it travels through. Okay, an example of that, here we have sound, which is a type of wave that is traveling through a medium. These are different mediums. We have different gases, air, helium, which you're not supposed to breathe in, even though it's really fun to hear your voice really high, liquids, and solids. Notice as the material changes, so does the speed. And it is apparently dependent on temperature. I wonder why that is. It's almost as if the speed at which these molecules are moving affects the way that energy is being transferred. Wow, science! Okay, so velocity wave formula. So velocity or speed is equal to the frequency, which is, remember, 1 over t, times the wavelength, which is crest to crest, trough to trough, or a y that has been flipped upside down. Alright, or you can rearrange that in one of three other ways. Here's one of them, equaling wavelength. The other one would be that I took frequency. I am in the middle of a lesson, people. Okay, I'm back after that was rudely interrupted. Alright, anyway, so frequency. That should equal, right, the speed divided by the wavelength. Right? So those are your three variations of the same formula. But it's very important to remember that velocity does not change with frequency. No. No, 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 no. Doesn't do it. Does not change. The only time it's going to change is when the medium changes. Alright, so if it's going from water to air, those are two different mediums. So the sound would travel at two different speeds. I don't know why I'm talking like this, but that's what I want you to know. Okay. Oh, hey, look, I already did the work for this. Cool. So here we have a practice problem. The first thing that you're going to want to do is figure out the frequency that Bert is making with his rubber ducky. And what we have here, actually I think Ernie's the one that has the rubber ducky. Oh well. Anyways, so frequency is cycles per second. So in this case, he's hitting it twice for every second. So 2 over 1, that gives you 2 hertz. And then to find velocity, you take that frequency, multiply it by your wavelength. Why does that look like an A? That's better. Times your wavelength, which is 0.25. There, 0.25 meters apart. And you're going to figure out the velocity, which is about half a meter a second. Now that you have the medium, remember this doesn't change. So now you're going to increase the frequency to 5 times. That's going to affect the wavelength, not the velocity. So you should get a new wavelength of 0.1 meters. Alright, so next thing we have here is dealing with a pendulum. So a pendulum is a object that goes back and forth, right? And this is going to be affected by the length of the string and gravity. So how long it takes is affected by the string, the length of it, how far it is to the ground, and gravity. Here is a whole video that I have for you about an experiment, but hopefully you did the experiment, so you don't need to watch this video. If you do, it's pretty crazy how they don't have anything on their bed, and this guy just appears in random spots, but mostly it's an okay video. I do want to go over one of the problems while I have you here from the homework, so I am going to see if I have that. Nope, I don't want to show you the test. Here, I'll pause it for a second. Okay, I'm back. I found it. Sweet. So I gave this the other day. I know these are about pendulums and identifying things that are happening in it. So let me scroll down to the right part of it. There we go. So we have a pendulum, and it swings once every second. So it's called a seconds pendulum. And it was came up with in this place called England, Cambridge. And the length of the pendulum, can I, pens, color, red. Alright, so the length of this pendulum, always does that. Alright, the length of this is 0.9942 meters. And I want to know what the acceleration of gravity is there. So our period is equal to 1 cycle, so back and forth, which is 2 seconds. Right? Swings once every second, so back and forth would be 2 seconds. So 2 equals 2 pi times the length of the string, which is 0.9942 over g. And I think the hard part with this is the math, so or at least the algebra part of it. So I'm going to go through that and show you how to do that easily. I'm going to do it over here. So this does not go to this stuff right over here. I'm just going to do it on the side here. So the first thing you want to do is start with something that's far away. So this 2 pi. So 2 divided by 2 pi, we'll get rid of the 2 pi on this side. That'll equal the square root of 0.9942 over g. The 2's should cancel out, and you're left with, I apologize, this is all over, but I don't have enough room to actually show you this on this paper. You have plenty more room than I do. So you have 1 over pi equals the square root of 0.9942 over g. So then you need to get rid of this square root, so square that'll cancel that out, square that over here. So now 1 over pi squared equals 0.9942 over g. Multiply g on each side. Oh man, this looks, it's all kinds of sloppy, but oh well. I'm going to go with it. So you end up with g times 1 over pi squared. I'll put an extra parentheses in there so you can see that those are separate. 0.9942 divide by this 1 over pi squared, and you should end up with 9.812 meters per second squared, which is that answer over here. Alright, I'm going to call it quits there. It's been talking too long, and I made a whole bunch of sloppy mess here. Hopefully you can slow this down and see what I was doing. Or just stop in and ask me questions. I'm really sorry. I don't know why I was so sloppy. Okay, I'll see you later. Goodbye. Why are you still here? I said goodbye. Freaking me out, man. Freaking me out!